The Contherm scraped surface heat exchanger is particularly suited for processing viscous, sticky, or particle-laden products that can be pumped. It can be used in a broad range of processing environments, including heating, pasteurization, sterilization, cooling, slush freezing, and crystallization. Product is pumped into the lower tangential port of the Contherm heat exchange cylinder. As it flows through the cylinder, the product is continuously kept in a turbulent state and removed from the cylinder's precisely finished walls by scraping blades. This scraping action results in thin film heating or cooling of the product, an inner surface free from fouling deposits, and a correspondingly high heat transfer rate. Heating or cooling media flows in the annular space between the Contherm's heat exchange cylinder and the insulated jacket. Steam, glycol, brine, or water enters the heat exchanger from the top end and exits the bottom. Direct expansion refrigerants enter from the lower end and exit from the top. Before performing any maintenance on the Contherm, ensure that product flow and the rotor motor are disabled, that no CIP solution remains in the piping, and that the equipment is not too hot or too cold for handling. Before removing any clamp, make sure the hydraulic system is operating correctly by checking for leaks, checking the level of fluid in the tank, and cycling the piston up and down, actuating the hand-operated valve in both directions. With the hydraulic piston in the fully up position, loosen and remove the 7-inch clamp holding the lower product head to the cylinder. Keep hands and feet clear from under the lift system. Slowly lower the head assembly and rotor out of the Contherm cylinder. Be careful touching the blades, which can sharpen through wear against the cylinder. Remove the blades by swinging them slightly out, removing the blade from the lower pins, then swinging backwards to remove the blade from the top pin. Take care to avoid injury from blades sharpened by use. To remove the upper seals, compress the seal spring and twist to disengage the seal shell tab from the seal locking pin, and slide the seal assemblies off the end of the rotor. Be sure to check the seal locking pins for damage or wear. If the pins are damaged and do not hold the seal assemblies, it may be necessary to replace them. When replacing the lower seals, be sure to use the helper plate to support the weight of the rotor, as there should be no reason to lift the rotor by hand. The cutout dimension in the helper plate will vary depending on the diameter of the rotor supplied with the Contherm. Adjust the lower product head to a comfortable level. Then insert the plate between two open blade pins and slowly raise the rotor to trap the plate in a ready-to-be clamped position. Clamp the helper plate to the cylinder. Before lowering the rotor, it's very important for units equipped with a rotor hold-down bolt that the bolt be removed. This is done with a 3/8-inch hex key. Once the plate is secure and the rotor hold-down bolt is removed, slowly lower the rotor until it's supported on the plate. Continued lowering will pull the lower product head down and away from the rotor bottom, exposing the lower seals. Remove the seals in a similar method to the upper seals and replace with new seals. If the unit has no lower seals and is equipped with an inboard bearing, refer to the bearing section for more information. Before raising the product head, be sure to inspect the bottom rotor end and the lower bearing for wear or damage. For a better view of the lower bearing area, remove the 5-inch clamp and the product head to expose the lower bearing area. Inspect the bearing for wear and damage. To replace the bearing, unfasten the bearing cap from the hydraulic lift beam and take it to a workbench for further disassembly. Refer to the section on bearings for service on the inboard or outboard lower bearing. Reassemble the lower head and bearing assembly. When raising the lower head around the rotor end, ensure that the rotor is centered to prevent damage to the bushing. Take special care to avoid pinching the slinger ring that sits on top of the bearing housing. The slinger ring is used to divert foreign matter away from the lower bearing area during operation. Correct reinstallation of the slinger ring will increase the life of the lower bearing assembly. Raise the rotor and lower head assembly until the blade pins push against the helper plate, trapping it in place. Remove the clamp, and then slowly lower the rotor and remove the helper plate. Raise the rotor inside the cylinder to reassemble the unit. Make sure all blades are reinserted and that the blades are installed correctly. The beveled edge should be facing the rotor, away from the cylinder, and the blades should be pointing in the direction of rotor spin. Failure to insert the blades correctly will lead to loss of heat transfer. When raising the rotor inside the cylinder, make sure the blades do not catch on the edges of the cylinder wall. If they catch on the cylinder, the unit will be damaged and the blade may need to be replaced. Use one hand to guide each blade set inside the cylinder, while the other hand controls the hydraulic valve. The hydraulic flow control should be adjusted to allow only a slow raising speed, which allows time to ensure the blades are correctly positioned. Replace the 7-inch product head clamp, taking care to orient it correctly. Do not over-tighten the clamp bolt. No more than 20 foot-pounds or 25 newton-meters of torque should be applied. Do not forget to replace the self-locking rotor hold-down bolt. The bolt should be tightened down until further tightening causes the rotor to turn. Reassembly of the unit is now complete. Proper maintenance of the rotary seals are necessary to reduce wear on components, reduce product losses during operation, and to ensure product sterility. Contherm seal types include standard carbon single seals, carbon flush double seals, hard-faced single and double seals, double Hund seals, and other seal types for specialized applications. The simplest rotary seal type is the 2-inch standard carbon single seal. This consists of a ring-shaped carbon seal face inserted into a stainless steel seal shell. The seal is mounted to the rotor shaft and spins with the shaft. The seal face spins against the stationary seal bushing mounted in the product head. A spring applies constant pressure on the seal face against the bushing, and an O-ring on the inner diameter seals against the rotor shaft. When the carbon face is damaged or wears out, it can be replaced inside the shell. The 2-inch seal face assembly can be purchased as a complete unit with shell, carbon face, and O-ring, or the components can be purchased separately. To check for damage or wear to the seal face, closely inspect for surface irregularities, which may indicate uneven wear. If the face surface is worn to the point where it no longer protrudes from the seal shell, the face must be replaced. Check the surface for any cracks or chips. Even the smallest cracks or chips will cause the seal to leak, requiring replacement of the seal face. A slightly roughened or pitted surface may be repairable by lapping the seal face to a perfectly flat condition. Use a granite lapping plate calibrated to 1 micron surface flatness. Clean and inspect the plate thoroughly to ensure the surface is perfectly flat. Affix lapping film of 30 micron grit to the plate and lightly rub the seal face over the film in a figure 8 motion until any defects have been removed. Change the film to the finer 15 micron grit and repeat the lapping process until the face is polished. Wipe away any remaining residue. If defects cannot be erased by lapping, or if the lapping reveals any hairline cracks in the seal face must be replaced. Remove the old seal face by chipping out the carbon seal, taking care not to scratch or distort the stainless steel shell. Wash the shell with soapy water to remove any residue and rinse thoroughly. Check the shell for eccentricity, bent or worn pin tabs, or other damage. Repair or replace as necessary. Heat the seal shell in an oven to 290 degrees centigrade, 550 degrees Fahrenheit. This will expand the shell to allow the carbon face to be inserted easily. Do not attempt to press in the carbon face without heating the shell, as this will damage the seal face. Once the shell is heated, the carbon insert will push in easily. The stepped surface of the carbon insert should be facing toward the bushing. Allow the shell and carbon insert to cool at room temperature. Do not use water to cool the seal assembly, as this will crack the carbon face. After the assembly has cooled, lap the seal to make sure it's perfectly flat. Lapping is required before use of any new carbon face to ensure good seal contact. After lapping, lubricate and insert a new O-ring into the groove in the inner diameter of the shell Do not use the old O-ring. It may be worn with flat areas, creating an imperfect seal. Before assembling the new seal onto the rotor, check the seal spring to ensure it is not bent or worn and still functions properly. Standard carbon double-flushed seals use identical 2-inch seals and also an additional 1.5-inch seal face and shell. Maintenance, carbon face replacement, and installation of this small rotary seal is identical to that of the 2-inch seal. In addition, the 1.5-inch secondary seal is available as a complete replaceable assembly for easier and faster maintenance. The hard-faced seal is composed of silicon carbide material and used in applications requiring a longer operating time between seal maintenance or with highly abrasive products that would quickly wear the carbon seals. This longer-wearing seal material is pre-installed into the seal shell and precision-lapped in the factory with diamond-impregnated lapping film. When the hard-faced seal wears out or is damaged, the whole seal assembly must be replaced. Do not lap the hard-faced seal before installation. The hard-faced seal is replaced in a similar manner to the carbon-faced seal. The chrome oxide stationary seal bushing has a much longer wear life than the carbon seal face and so requires less maintenance. But the bushing should be checked for chipping or cracking whenever the Contherm is disassembled. Any damage to the bushing surface will allow the seals to leak. The bushings for both the standard carbon face and the hard face rotary seals are identical. The flush double seal bushings have 2 bushing surfaces and can be purchased as a full assembly including bushing surfaces, O-rings, set screws, and quick connectors for the flush lines. To remove the seal bushings, first remove the top or bottom product head assembly from the Contherm and take it to a workbench. The bushings are fixed into the product head using 3 set screws. Loosen the set screws with a 5/32 inch or 4 mm hex key until they protrude into the inner diameter of the housing, and remove the bushing from the product head. Inspect the head for damage. Before replacing the bushing assembly, be sure to use new O-rings and lubricate them. Install the new bushing into the product head. Verify that the bushing is positioned absolutely flat against the product head. Insert the 3 set screws and tighten to a recommended torque of 10 foot-pounds or 15 Newton-meters. Do not over-tighten these screws, as this may distort the bushings. The flush double bushing assembly has 2 bushing surfaces and 2 O-rings, but is installed with identical set screws. Before removing the flushed bushing assembly, unscrew the flushed hose quick connectors using a 9/16 inch wrench. When reinstalling the double bushing assembly, care must be taken to align the flush connectors with corresponding orifices in the product head. After reinstalling the bushing housing, reinstall the flush connectors using pipe tape to ensure a good seal. The Hun seal is a heavy-duty spring-loaded hygienically designed rotary seal that allows long production runs without requiring seal maintenance. It provides extra long life and is used in the processing of highly abrasive products. The Hun seal requires motor and rotor spline modifications and is not interchangeable with other seal designs. Refer to the manual for a complete description of Hun seal maintenance procedures. Good bearing maintenance is the key to prolonging the life of all wear components on the Contherm and keeping the unit operating at maximum efficiency. Loose or damaged bearings will negatively affect the life of the rotor, the cylinder wall, the scraping blades, seals, and the motor spline coupling. The highest wear is on the lower bearing. This area should be visually checked whenever the rotor is lowered for blade or seal maintenance. The lower bearing is housed in the bearing cap at the bottom end of the rotor. To check the bearing condition, rotate its inner race with a finger. If it turns smoothly, the bearing is good. If it does not turn smoothly, or if it feels rough, replace the bearing. To get access to the lower outboard bearing, remove the rotor hold-down bolt. Release the 5-inch clamp and lower the bearing cap, leaving the rotor and product head in place. The bearing cap can be taken off the hydraulic lift beam assembly by removing the 2 bolts located underneath the cap. Remove the 3 socket head cap screws from the bearing cap cover plate using a 5/32" hex head key. Press the lower bearing with rotor end out of the bearing cap. Inspect the rotor end for signs of wear. Replace as necessary. To reassemble, first press the rotor end into the new bearing. Then press the new bearing into the bearing cap, making sure the rotor end flange is facing up. Make sure the bearing spacer is in place before pressing the bearing back into the cap. Ensure that it's seated completely and squarely into the bearing cap. Replace the cover plate and reattach the bearing cap onto the hydraulic lift beam, making sure not to tighten down the 2 bolts. These bolts are left only finger tight to allow centering of the bearing assembly against the cylinder. Lift the bearing assembly onto the product head, making sure to install the slinger ring and center the assembly. Correct reinstallation of the slinger ring will increase the life of the lower bearing assembly. Tighten the 5-inch clamp, not more than 20 foot-pounds or 25 Newton meters. Tighten the 2 bolts, making sure to use lock washers. Do not forget to replace the self-locking rotor hold-down bolt. The bolt should be tightened down until further tightening causes the rotor to turn. Some Contherms are equipped with internal or inboard bearings. In this configuration, the lower rotor shaft end rotates in a carbon thrust ring, and the rotor does not protrude out of the product area. The advantage of this configuration is that no lower product seals are required, thus maintenance is reduced. On the 2-inch and the newer style 3-inch tangential head, the inboard bearing is located in the same position as the seal bushings and is accessed in a similar fashion. Release the 7-inch clamp and lower the product head using the helper plate to hold the rotor in the cylinder. Visually inspect the bearing sleeve for wear and replace if necessary. Inspect the carbon thrust ring for cracks and wear and replace if required. Release the 7-inch bearing clamp at the bottom of the head to remove the product head from the inboard bearing plate. The retainer ring and carbon thrust ring assembly is secured into the product head by set screws, which must be loosened before pressing out the assembly. Carefully chisel the carbon thrust ring out of the stainless steel retainer ring similar to the procedure for carbon face removal in the standard seal video, making sure to avoid damaging the stainless steel ring. Clean the retainer ring with soapy water. The carbon ring should be able to be press-fit into the retainer. Do not force into the retainer or you may damage the carbon. If required, please review the Contherm instruction manual for proper heating and press-fit requirements. Again, this procedure is similar to the standard seal removal and replacement. Then replace the thrust ring set screws through the bearing plate. Reattach the product head onto the hydraulic lift beam using the 7-inch bearing clamp. Place the bearing sleeve back onto the rotor shaft end using a food-grade grease to keep the bearing sleeve on the rotor while lifting the product head into place. Lift the product head assembly onto the rotor end, making sure the bearing sleeve slides into the thrust ring. Reassemble unit as required. The drive bearings are located on the top of the vertical mounted Contherm and are assembled as a set of 2 bearings inside a bearing housing. These upper bearings are larger than the lower outboard bearings and so require less maintenance than the lower bearing. If the bearings are damaged or worn, they must be replaced. The disassembly procedure varies depending on whether the motor drive is direct coupled, belt and sheave driven, or hydraulically driven, but the basic procedure is the same. This video will go through the procedure for the electrical direct drive mount only. The specific procedure for other hydraulic mount types can be found in the Contherm instruction manual. To disassemble the bearings, it's necessary to first ensure that the drive motor is disconnected. Then remove the rotor from the cylinder and remove the coupling guard over the flexible drive coupling. The flex elements of the flexible drive coupling are matched halves and should be kept together and reassembled together on the same unit to ensure the couplings are balanced. If there are any fatigue cracks, discoloration, or surface cracking, the elements should be replaced as a pair. Remove the 5-inch clamp on the product head and remove the bearing housing assembly. It may be necessary to loosen the keyway set screws on the lower and/or upper coupling hubs and slide them up or down in order to have enough room to remove the bearing housing. To reinstall the drive bearing, attach the coupling hub to the drive shaft and tighten. Attach the assembled bearing housing onto the Contherm product head and reattach the 5-inch clamp. After reinstalling the flex elements and tightening all bolts, do not forget to reinstall the coupling guard. This is a safety requirement. A number of different blade materials and blade styles are available for different applications. Despite the material and style differences, however, all blades require frequent maintenance to ensure efficient heat transfer. Blades are the critical wear component of the Contherm. Worn blades will not scrape the cylinder inner wall correctly, reducing heat transfer and accelerating uneven wear in the cylinder wall. Blades should be inspected every time the Contherm is opened for service. To inspect the blades, open the Contherm and lower the rotor. This procedure is discussed in the introduction video. Inspection should include complete removal of the blades and a visual check of the condition of the rotor blade pins and standoffs, or blade tabs. When replacing blades, a complete set of new or dressed blades should be used. This will minimize maintenance downtime and reduce potential uneven wear on the cylinder wall. Blades should swing easily on the pins. Check blade pins for bent or worn areas. Bent pins may be straightened, but excessive wear on a pin may require the pin to be replaced. See the manual for more information. Check the blades for cracks, broken edges, or damage to the pin slots or inserts. If the scraping edge of the blade is razor sharp, the blades should be dressed before replacement on the rotor pins. Dressing the blade using a standard flat file will increase the heat transfer capability of the blade and minimize uneven cylinder wear. The scraping edge should be filed off to give a flat edge of approximately 0.5 millimeters or 20/1000ths of an inch. Clamp the blade in a vise and pass the file over the blade scraping edge to create a flat edge. Take care to file the least amount of material off the edge in order to maximize the useful life of the blade. Blades can be dressed repeatedly as long as the total blade width is not below 32 millimeters or 1¼ inches. At narrower blade widths, the blade should be replaced. A narrow width blade will not contact the cylinder wall at the correct angle, and heat transfer will be inefficient. When reinstalling blades on the rotor, make sure that all blades are installed and that they're in the correct position. Blades installed backwards will lead to a severe loss of heat transfer capability. In order to avoid damage to the blades when raising the rotor, make sure that the blades are pressed against the rotor and do not hit the cylinder wall as they go into the cylinder. If you feel you're experiencing any difficulty with the hydraulic lift, please contact Alpha Laval for assistance. Some common troubleshooting items and solutions are: system does not operate smoothly. Either air in the system or oil contamination can cause this. You can bleed air by raising and lowering the lift several times. Assure that the cap on the reservoir tank is free of debris and that the oil supply level is acceptable as per the supplied Contherm instruction manual. If the oil is water contaminated, it will have a creamy, foamy appearance. In this case, drain the contaminated oil from the system and replace with clean oil. The hydraulic lift system will lower the rotor but will not return. This can be caused by a blocked or defective stack valve. Disconnect lines to the valve and inspect for any restriction. Hydraulic lift pump not operating correctly. Inspect the wiring and fuses to assure polarity, voltage, and that the site fuses or breakers are on. Incorrect hydraulic lift pump and incorrect stack valve tubing. Assure that the pressure or out of the lift pump is attached to the in of the stack valve. U-cups are damaged or twisted. Inspect U-cups for damage by disassembling the hydraulic lift cylinder in the Contherm and replace as per the provided instruction manual. Oil leakage from the bottom of lift cylinder around piston rod. Oil leaking around cap at top of cylinder. The product cylinder can be made from various types of metals, depending upon the application requirements. Inspect the cylinder by lowering the rotor, and visually inspect the inner cylinder walls for any pitting or unusual scoring marks. If any of these items are found, please consult your instruction manual and contact Alfa Laval for assistance. To ensure the highest possible performance from your Contherm, it's important to inspect the spline end to assure it's undamaged and clear of debris. In addition, inspect the blade pins and pin slots to assure they're not distorted, with an opening not greater than 1/8 of an inch or 3.2 millimeters. Lastly, the rotor end should also be inspected for excessive wear and replaced if necessary. If any irregularities are found, please consult your instruction manual and contact Alfa Laval for assistance.